All right. Good afternoon, good morning, everyone. Thank you so much for joining the part two of GoPHA's webinar. Continuing on part one, we are going to this discussion or this webinar is exploring alternatives and substitutes and how do they align with the future of waste management? What are alternatives and substitutes? We're going to talk about it in just a minute. I am Saloni Sharma. I am the Policy and Advocacy Coordinator at GoPHA, and I welcome the speakers and everyone who's attending today. And let's begin. Today's speakers, we have Mr. Marco Versari, the president of BioRepack, and Dr. Katrina Nauer from the CDO of the Bottle Consortium. Some housekeeping rules. The presentations will be 10 minutes long. We will have a Q&A session after the presentations, but please feel free to put your questions in the Q&A chat. And if you like to address questions to specific speakers, please feel free to mention their names next to the question. And we'll monitor it and we'll collate it for the Q&A session. A little bit about GoPHA. GoPHA is a nonprofit organization. We're based in the Netherlands and also in the US. We work with three work streams in policy and advocacy, communication and education, and science systems and programs. All of it are interconnected, and the goal is to create an ecosystem where we can integrate alternatives and substitutes, as they call it in the treaty, but bio-based, biodegradable, compostable materials that are made by biotech and bioprocesses into the discussions of the treaty. And we believe that they serve a purpose and they contribute to the goals of the United Nations Plastics Treaty. A little bit about this treaty. The treaty or the international legally binding instrument, which is still under development. The discussion started in 2022. And since then, there have been 4 negotiation sessions where countries get together to discuss different provisions to develop a legally binding instrument, potentially, to address the impacts of plastic pollution and the challenges that it comes with. The role that alternatives and substitutes play in this treaty is basically to support the development of the treaty and broadly addresses it broadly addresses where these materials can contribute in the treaty by ensuring that they are suitable, sustainable, and safe. Some of the things that are not properly defined in the treaty yet, but that is the goal to avoid regrettable substitution, which is where these materials come up. And in its current form, the treaty significantly undervalues the potential of these materials, which is why we as experts in this platform contribute to educating policymakers, other NGOs, and other stakeholders involved to present this as one of the many solutions being discussed in these negotiations. The challenges that alternatives and substitutes face at the moment is the lack of harmonized information on their suitability. What are the types of chemicals and additives that are used in them, and in general, global assessment criteria and standards for what comes to be suitable alternative. The significance of this treaty is that it can drive the shift towards renewable alternative materials in critical sectors and positively impact some of the many environmental outcomes being discussed in the treaty. And it can also then support the growth of this industry by promoting use and increasing demand of sustainable alternatives. The potential impacts, the nations translating these treaty provisions on alternatives can bring in their own legislations for such materials. There can be an increase in research into alternatives and substitutes, and also impact positively the market development and growth in the industry. A little bit about how GoPHA has been involved in the treaty negotiations. GoPHA is a UNEP accredited NGO and has been actively participating as an observer in the negotiations. And we contribute by developing and disseminating educational resources about alternatives and substitutes, and engaging with national delegations, and also collaborating with other knowledge organizations and IGOs, intergovernmental organizations, working towards making a more holistic treaty. For today's topic, we are looking into exploring the technical, practical, economic aspects of integrating alternatives into the waste management systems that exist today, and understanding the technology infrastructure which is needed to meet the UN treaty's requirements, and how alternative materials fit within recycling and composting systems. Having said that, we'll start with our first speaker. I see Marco is here. Hi, Marco. Welcome. And we'll begin then. The floor is yours.
Thank you so much. Sorry, it was a little bit complicated to join you, but now I'm here. So can you share for me the presentation in order to be much easier? Perfect. Thank you so much. Can you go on? Thank you so much. The next one, please. Can you?
Marco, can you?
Do you hear me?
We can hear you, but do you see your screen? The screen, or because you are two slides ahead?
Yes,
already.
I see it perfectly.
Good.
Okay. So can you remember me how long is the time? For me, it's 15 minutes, is it?
It's 10 minutes. But
yes.
Yes.
But if you go over a little bit, it's okay.
Perfect.
That's also fine.
Yeah.
You add for me. So BioRepack is the national consortium for the organic recycling of compostable packaging. Is the seventh consortium under the umbrella of CONAI. CONAI is the National Consortium for Packaging Recycling, and below this umbrella consortium, there are 7 vertical consortia, starting from plastic to glass, aluminium, metals, and also compostable packaging. Next one. I don't want to take too much time to explain what we are, then we can have some time for the questions. So why we have a body like BioRepack acting in Italy? First, because we have already an umbrella system in Italy. The second reason is because in Italy we have since at least 30 years a well-established food waste collection. And since the very beginning, compostable packaging and plastic, starting from bags or carrier bags or fruit and vegetable bags, are accepted as a tool to have a more efficient collection of food scraps at home and a more efficient treatment of food scraps and garden waste in the composting and ID plant. And for this reason, Italy is the country with the highest quantity of food scraps collected per person per year, and Italy is collecting more than 50% of the total amount of food waste collected at European level. thanks to this strict connection between food waste collection and compostable material, Italy developed an important industry of compostable plastic resin production, and with a wide range of converting compostable plastic industry, starting from, as told before, waste bags, carrier bags, fruit and vegetable bags, but also cutlery, other rigid items like cutlery, and also in the last years, coffee capsules. The next one, please. So this is what we have to do. That is the same of the other EPR system, at least acting in Italy. So we have to promote the separate collection, in our case, a separate collection of compostable packaging. We work together with local authority in order to have a good collection of compostable packaging, and we pay local authority for this. We monitor the production and the consumption of compostable packaging, because this is the way to pay local authority to ask for the money to the producer of compostable packaging, and to pay local authority for the collection, transport, and organic recycling. And one of our last but not the least is the education. So we are making a lot of effort, financial effort, with commercials, for example, in all the Italian TV, in order to inform citizens how to recognize compostable packaging and where to put it. And I show our main commercial. The next one, please. So these are some examples of compostable packaging that we manage. The first information is, of course, the producer that can join Biorepack are the producer of compostable packaging according to the harmonized standard EN 13432. Then there is also an interest on the renewability, but this is not for all materials, because only fruit and vegetable bags has a mandatory renewable content, that is today is around 60%. Also cutlery, according to the Italian single-use plastic directive transposition, cutlery has to have 40% of renewable content, apart, of course, the mandatory compostability. And of course, all the food and contact needs by law. Next one. Okay, some data about how compostable plastic meets the food waste collection system. So by law, this is the first important message. So compostable packaging have to be collected together with food waste by law. So it's not if yes, if not, in some technologies, yes, some technologies not. So all plants has to collect and treat together all compostable materials. It means food waste, garden waste, paper when it's compostable, and if compostable, and also compostable packaging. Food waste, I don't want to repeat what we already see, but this is the most important part. So it's important for the Italian government to have a high collection of food waste in order to close the loop of carbon, in order to produce both biomethane and compost, in order to have fertilizer to maintain soil fertility. Next one. Some numbers. So we are young because the study was approved in 2018, and we started with our first contracts with a local authority or group of local authority in 2020. But after less than 4 years of activity, you see that we cover the more than 70% of the Italian population. This is the numbers of year 2023. Now we are more than 80% of the Italian population, and you see that there are areas where close to 100% of the citizens are involved in the collection of compostable packaging and, of course, of food waste. We have contracts with more than 1,400 councils, taking account that in Italy there are more than 8,000 councils. We have over than 300, well, close to 400 agreements. That means that we have a contract with groups of also groups of council in order to make easier treatment of the data, of course, and of the money that we transfer directly to local authority. We give more or less around 10 million euro per year to the council for the collection, the transport, the organic recycling of compostable packaging. Our main problem is to face is the quality of the collection of the quality of the food scrap collected, because are still contaminated by plastic. You see that there is more than 4% of plastic in bio waste, and this means that because the plastic, non-compostable plastic, has to be removed by the environment, by the system, we lose 15 recycling points of because for the dragging effect, the action to remove plastic drag also organic compostable materials like food scraps, but also, unfortunately, compostable items. This means that more or less in big numbers, between 75 to 80% of the total amount of the compostable packaging used by Italian citizens arrive correctly to compostable plant, but our recycling result the past year around 65%. This means that we lose 15 recycling points, but not because the compostable material are not composted. So it's simply because the impurity of the food waste collection that need to remove not compostable items from the environment. The next one, please. I'm going to the end of my presentation. These are simply the number of compostable plastic that are expected to be managed by our consortium. So we are speaking of small numbers in comparison with the total amount of plastic sold in the Italian territory. The next one. We are spending, as I told you, a lot of effort in communication through TV commercial, digital communication, a lot of local projects with local authority in the schools, with the citizen and so on, events, media. I want to show you our commercial that was broadcasted in all the main Italian TV. The next one. Next. So these are numbers, but this one is in Italian, but with the subtitle.
Anita.
I don't know if I didn't hear the volume, no volume.
I'm going to check that for you. Just a second.
But don't want to take time, but just to show that this was
Alla fine sono venuti tutti.
Proprio.
I see that it don't work, but okay, is a simply way to show that compostable packaging has to be collected together with food waste, and this was broadcasted in all the main Italian TV. Then we are spending more than now is much more than 200 euros per year with a local project with the local authority in order to have specific project in communication on compostable packaging. Next one. And this is my final remarks. So what we are going to do in the next month and years. First, we wanted to cover more and more Italian territory in order to reach, if possible, 100% of the Italian population. And next year, and this is what will be the most important project of Biorepack, the adoption of a pictogram that will be adopted by all the value chain, from the producer of the packaging, the supermarket chain, local authority, and also we launch our TV campaign next year in order to have a very simple design, a very simple packaging, how to recognize all compostable packaging that will be collected and converted in compost through Biorepack. Then, of course, we are working with the Italian composting industry in order to support them to have a more efficient treatment of food scraps, and in this way to have a more efficient conversion in compost and biogas of compostable packaging. And we are working every day with the local authority in order to push food waste collection and to push a high quality food waste collection. This is, I'd say, more or less the main remarks from my side, and then I would be happy to answer to your question or to go in some specific arguments if you want to go in deep. Thank you so much.
Thank you. Thank you so much, Marco. We will take up questions towards the end. So I guess it gives people some time to digest the information and put their questions in the chat. For now, we move on to our next speaker, Katrina. Hi, Katrina. The floor is yours.
Thank you so much. Everything looking okay over there in terms of slides?
It does, yes.
Great. Well, thank you everyone for tuning in today, and thank you to GoPHA for the opportunity to talk about the work that we're doing in the Bottle Consortium. So I am Katrina, or Kat Knauer. I'm a senior researcher at the National Renewable Energy Laboratory. We are a Department of Energy nonprofit national lab in the United States, based in Colorado. And as part of NREL, that's what we shorten the National Renewable Energy Laboratory to, I am the Chief Technology Officer of a research consortium called the Bottle Consortium that I'll briefly introduce. And today I'm going to talk about the role that sustainable, or what we are calling sustainable alternatives, can play in the emerging and developing novel waste management systems that are coming out of things like the UN Plastics Treaty the EU Single Plastics Directive and other types of policy being passed around the world. I do want to emphasize that we are a research laboratory, so we are not necessarily involved in any kind of policy or decision-making at a senior government level. We're simply scientists that are trying to generate data that we put out into the ecosystem, into the public eye, so that we can make data-driven decisions in big treaties like the UN Plastics Treaty. So I want to just start by briefly introducing the BOTTLE Consortium. So BOTTLE is an acronym. This does not mean by any means that we only work on plastics bottles. So this tends to be confusing for folks that thinking our only focus is BOTTLE, but BOTTLE stands for Bio-Optimized Technologies to keep thermoplastics out of landfills and the environment. So we are a research organization funded by the US Department of Energy. We're based out of NREL, but we are 8 institutions total across the US and also abroad. So we're a group of both universities and national labs. And we were created with the goal that I think many of us tuned into this webinar had, as well as the goal of the UN Plastics Treaty, to go from a linear to a circular economy. Our ultimate goal in BOTTLE is to develop technologies that allow us to take carbon from the earth, whether that be fossil-based or bio-based, once, and keep those carbons in infinite circulation so that we no longer have to rely on the earth's resources to continue to produce materials. So we're highly focused on sustainable alternatives. We're also focused on how do we manage plastic waste that exists today. So we work on both streams, and we also do a very comprehensive techno-economic analysis and life cycle assessment approach to the way we conduct research, and have an excellent TEA and LCA team as part of BOTTLE. And our ultimate goal in the BOTTLE Consortium, because we're Department of Energy, we're hyper-focused on reducing emissions and reducing the climate impact that plastics have on our planet. And so our hope is that the transition to a circular economy will reduce the primary first-generation production of plastics and thereby reduce the emissions associated with plastic production and use. And this was a wonderful study done by the Bardot Group at ETH Zurich back in 2021 that we like to reference quite a bit. So this group did a comprehensive life cycle assessment and planetary boundary analysis on whether or not it could actually be possible to get to a net zero emissions plastics supply chain. And the study showed that that is possible to do. And it requires a combination of 2 essential changes to our current supply chain. The first is a high utilization of biomass. We need to bring more biogenic carbon into material utilization to help us reduce emissions and get to our climate goals by 2025, 2030, and 2050. So this is incredibly important. We need more bio-based materials into our supply chain, but that's not enough to meet the expectation, or not enough to get us to a net zero emissions economy. The second very, very critical aspect here is high recycling rates. So the study showed that net zero emissions could only be achieved through the high utilization of bio-based content and high recycling rates as high as 70%, which, as we all know, we're nowhere near today. And so this is our big goal in the BOTTLE Consortium, is to bring in more bio-based materials to the market, but also enable the recycling of those materials. And we have to think about multiple end-of-life options to do that. And so within BOTTLE, we're not only just looking at compostability and biodegradability, we're very, very focused on depolymerization of these materials as well, and how we can complement things like mechanical recycling. And one of our visions to do this is really looking at polyesters. So polyesters are a really great material to bring into that model of high biomass utilization and high recycling rates. A lot of polyesters can be sourced by bio-based feedstocks and derived from these biogenic carbon. They're still lightweight and durable and tunable. They bring in a lot of the performance metrics that we expect from plastics today. And the ester bonds in these backbones, these are much, much easier to break than carbon-carbon bonds, which make up the bulk of the plastics that we use today, such as polyethylene and polypropylene, which are very, very recalcitrant to any kind of chemical depolymerization and, of course, to biodegradation. These materials also have much shorter half-lives in the natural environment. So while not necessarily always fully biodegradable, most of these polyesters, if littered and lost to our natural world, have mechanisms and putative pathways to break down to safe molecules over the course of 1 to 5 years. And a ester bond is much easier from a sortation point of view. So when we think about waste management and how we improve the collection and sortation of plastics, we can minimize complexity. If more of these materials were polyester based, they can be sorted based on that polyester bond using emerging technologies at MRFs, material recovery facilities such as Near-IR. So down here is a couple of examples of partially bio-based or fully bio-based polyesters on the market today. My colleague Marco here talked about the great compostable materials that we're seeing come out in products. These are the most common ones we'll see are PLA, PBAT, PBS, combinations and blends thereof. And of course, PHAs are growing and emerging in the field of compostable plastics. And we are very focused on PHAs in the Bottle Consortium. And we are focused on PHAs because of all these materials, PHAs are considered the most biocompatible and the most biodegradable. So a notable study that came out from the Netherlands a couple of years ago showed that PHAs across all the bioplastics could break down in 10x more types of environment than other conventional plastics that were made for industry composting kind of conditions. And so we like PHAs for their biocompatibility, and also we like the tunability of the PHA structure that we can use as a handle to match performance of some of the materials today that we're expecting in terms of packaging and single-use materials. And so really quickly, I want to talk about one of the tunabilities that we like about PHAs is that we can make them from 2 different types of route. So the most conventional route for PHA production is shown here. This is the way that PHAs are made that we're using that are on the market today, that are in the compostable materials that we're using today. So this is a natural bio-based process that uses bio-based feedstocks that are hydrolyzed and acidified into fatty acids and sugars and other types of digestible intermediates that are fed into a fermentation where a bacteria can then digest those carbons and use that source to synthesize PHA granules, which are recovered and purified and processed into products for design and use. And there's several opportunities and challenges associated with the bio-based process. This process is tunable. You can change the copolymer design and backbone of the material based on the feedstock that you're using. The yields are 100% biogenic carbon, and these materials, as I already mentioned, are highly biocompatible, can break down in several types of environments. Some of the challenges of this supply chain is that the costs still remain quite high mostly from the raw material point of view. This raw material cost makes up 40 to 50% of the total production cost of these materials. And in some cases, you're competing with food crop, which the PHA community is trying really hard to move away from that and use more waste-based biomass feedstocks. Some other challenges here are low PHA conversion rates, and we don't have any control over the tacticity and stereochemistry of the polymer. And finally, I think one of the most common things we see with PHAs is some of the difficulties we have with processing. The melt temperature tends to be as high as, well, very close to the carbon degradation temperature. And so sometimes melt processing and conventional processing conditions can lead to degradation, and many PHA manufacturers have to add some copolymer design or other additives to help enable better processing. So there's another way to make PHAs, which brings in some supply chain resilience, and that is through a synthetic route, a chemocatalytically synthesized PHA pathway. So in this pathway, you can use either bio-based or fossil-based feedstocks. Obviously, we prefer the bio-based, but as we transition to having more of those available, it's nice to have this type of flexibility, again, for that supply chain resilience. We use these feedstocks to create monomers and building blocks. Mostly in this case, we're looking at lactones, various types of lactone-based chemistries that can be ring open, polymerized in a polymer reactor, and designed to create a very tunable PHA portfolio. So some of the benefits to using this type of approach is we have high control over molecular weight, the polymer tacticity and stereochemistry, the copolymer design, and this allows us to tailor very easily the PHA structure to create a vast portfolio of materials. Some of the challenges, another opportunity here too, is that precise control over tacticity and microstructure allows us to impart higher thermal stability of these materials. So these types of PHAs that we are engineering from lactone chemistries can be mechanically recycled, have much higher stability under thermal processing, while still maintaining that PHA structure and that backbone. So high biocompatibility and biodegradation rates. So this is all well and good, but there still remains some challenges here. And some of the challenges still remain in costs. You know, some of the reagents needed to synthesize these materials can still be quite expensive. And because of that, you know, the low cost of packaging and targeting of that can be challenging to implement. And the other, I think, major challenge here too is when we think about the UN Plastics Treaty and some of the new laws and rules that they're implementing around terminology such as natural polymers, we may lose that credibility for PHA here. If you're making it through a synthetic route, are they still going to be considered as natural, even if they're coming from a bio-based monomer? So these are some things to keep in mind as you try to improve the way we're developing these sustainable alternatives. But one of the reasons we're pretty excited about this PHA portfolio that we can synthesize from existing building blocks is when we think about the challenge of multi-layer films. So this is brought up somewhat in the UN Plastics Treaty because these materials are most notably affecting developing countries in terms of waste. So for those who are not familiar, multi-layer films, you can think about these sachets. So in the US, we associate this with something like ketchup and mustard, but in developing countries, they get nearly all products in this type of form factor: cooking oil, shampoo, toothpaste, you name it. And these are completely unrecyclable materials. They're not mechanically recyclable, they're not chemically recyclable, and they're certainly not biodegradable. And they're highly over-engineered types of materials that have been engineered to impart high shelf life and food stability, which is very good, but we've now found ourselves in quite a predicament because we have no recycling solution for these materials that are nearly 8 different layers of incompatible polymers. And while again, maybe this is not as big of a challenge in Europe and the US, this is a major challenge in countries like the Philippines and Indonesia, where these sachet packets make up nearly 52% of their plastic waste stream. And we currently have no alternatives to these that are recyclable or are biodegradable. And a lot of groups are trying to figure out how we manage this and how we manage it along the same lines of the new laws coming through the UN Plastics Treaty. And so our vision for the future and what we really hope we can achieve through the PHAs that we're making in the Bottle Consortium, with a combination of both the bio-based and biosynthesized PHAs and chemocatalytic PHAs, you know, from one basic kind of chemistry, we can tune the backbone to mimic and behave like the physical behavior of each of these layers that are required in a multi-layer film design. And so this is our major goal, is to move away from complexity. How do we make recyclable materials by a mono-material design? And I think this aligns very well with some of the goals outlined in the UN Plastics Treaty, is making materials more recyclable from a mechanical recycling point of view, and hopefully, what I hope, emerging chemical recycling as well. And then the backup plan here for these materials is they are compatible, biocompatible, and have a biodegradation route. So we're designing a multiple end-of-life option here. And this is very critical because end-of-life is absolutely essential when we think about long-term emissions and environmental impact of these materials. It's not enough to just reduce the amount of plastics we're using. It's not enough just to go to a bio-based plastic. We have to mitigate end-of-life. Marco showed the amazing work that Italy is doing to improve collections and composting of materials, which is excellent. And we have to also think about multiple options. So many think that we need to design for one end of life, and we really should be designing for multiple so that there's backup plans. So this is a study our team did just this past year, where we looked at the life cycle favorability of the end of life solutions, for example, a PHA polymer. So obviously the lowest, or not lowest, the worst that we can do is discard and landfill. We don't want any material going into littering into our oceans and waterways, and we don't want to be landfilling these valuable biogenic carbon materials. The next, improving the life cycle favorability is, if we have biodegradation routes. Again, this is kind of the littering piece, which we still do not want to happen, but we know these materials can break down, so it's kind of the backup, but it's still a poor from the life cycle favorability, of course, because it's littering. Composting is much better than landfill and littering, of course, and PHAs are considered highly compostable. And then we found that mechanical recycling and chemical recycling, based, of course, on the type of chemical recycling, keep that in mind, is one of the most favorable parts to manage these materials. So it really behooves us if we start thinking about the way PHAs can enter the recycling ecosystem and not just the composting ecosystem. When we think about long-term emissions and long-term value of these materials in our supply chain. And so we are hoping that we can start to convince the world that these materials are recyclable and should be kept in circulation for as long as possible. And the reason this is very important in the US is because unfortunately in the US, our composters are banning compostable plastics. The reason being is not because these materials don't break down, they do, but the reason is because they are very, very challenging to control the carbon oxygen balance. So it's leading to poor compost health, and they're trying to figure out how do they control and dose in plastic at a better rate so that they can control the carbon oxygen balance with nitrogen and phosphorus. But right now they don't have a great solution for it. And so unfortunately, a lot of our composters are banning these materials. So we need to consider how they can be recycled. And so this is our vision, is we hope that we can transition from our mostly petroleum linear-based supply chain to a fully bio-based polyester supply chain that can be recycled in infinite cycles and reconstructed back to these polymers. Our studies have shown, our life cycle assessments have shown an abatement of nearly 500 metric tons per year of CO2 if we only transition to 35% of our plastic supply chain to bio-based polyesters and recycled at a 70% recycling rate. And this is just at the end here is my final slide. I do want to point out that a postdoc from my team, Dr. Julia Curley, is now the CEO and co-founder of EsterCycle, which is a mixed polyester recycling technology. So right now, in the beginning of this technology, her current feedstock that she's taking into this process is a mixture of PET, PLA, and PBAT. She's expanding this to include PBS, PCL, and PHAs for the future. We're working with Glacier and Recology to conduct waste collection trials to see if we can sort bioplastics from municipal solid waste to funnel into the EsterCycle process. But overall, we have found through TEA and LCA studies that if this was imparted at scale, we could potentially reduce GHG emissions by nearly 50% per year, with at 150 metric tons per day, a $30 million net annual profit per year of the plant. So with that, I'd like to thank you all for your kind attention and happy to take any questions.
Yeah, thank you very much, Marco and Katrina, for those very enlightening presentations. Apologies, Marco, that you had to do the short version because I have actually seen your long version of the presentation, and which is actually quite interesting to see. So let's see. There are a few questions here, and I would like to start by asking. So I'm not sure who this one is for, but let me just read it out. So the first question is, or more of a comment with a question. We need specific enzymes or microbes to compost PHA. Therefore, we need to build industrial compost sites for it. How can we collect only PHA from consumers without any other plastic contaminants? Does anybody want to tackle that question between Katrina and Marco?
I'm going to let Marco go first, since I think he's more well versed with how compostables are collected than
Right.
I am.
I mean, I guess we can expand on the question to say, how does because Katrina, you mentioned that what about the elemental balance in the final compost, using bioplastics or bio-based materials. So first of all, do different kinds of bio-based materials need different kinds of microorganisms to compost? And the second part would be, do they actually alter the elemental balance between carbon, hydrogen, nitrogen, oxygen, phosphorus, for example? What have you seen, Marco? You have frozen, Marco. Not sure if it's just me or?
Do you hear me?
Yes,
Do you hear
yes.
me now?
Yes.
Okay. I'll try to be very straight. The compostable material represent more or less from 1 to 1.5 of the total amount of compostable material. So in few words, they do not change any carbon nitrogenum ratio. So, but this is academia. Compostable plastic are treated in composting and aerobic digestion plants since 30 years. So if someone do not want to use or treat compostable material in their plant, is simply because they do not want to do. For this reason, in Italy, we solved the problem very easily. Compostable material, compostable packaging has to be collected with. It's a matter of technology. Any compostable and anaerobic digester plant is able to do it. And firstly, because he has to do it. And there are no technical constraints in order to the problem is not compostable material. But this is a matter of which kind of material goes to a composting plant or reach a composting plant. But that compostable plastic, according to the European or ISTM harmonized standard, are perfectly compatible with the food waste collection and treatment industry. No doubt, we can, is a yes or not. It's not if, when, is yes or not. In this case, is yes. No doubt.
Okay. Yeah, I mean, if it is only 1 to 1.5% of the total compost collected, I think that the elemental balance, I don't know how much of that is really changing. But one other, just a follow-up question to that, Marco. There is also the issue in the US at the moment. For example, there is a list of materials that are listed on the National Organics Program from the USDA, where bio-based materials like plastics or you know, a PHA or PLA or whatever is not listed. So if they are not listed, that means that there is a possibility or a problem with the compost that the industrial composters are making for them to be designated as organic compost. I'm wondering whether in Italy you have had this problem or not, and how have you overcome that problem?
When I was president of the Italian Bioplastic Association, I made an agreement of I signed the protocol with the Italian Organic Farming Association for the use of mulch film, biodegradable mulch film. So the Italian Organic Farming Association is supporting the use of biodegradable and compostable items since 15 years. Because, so where is the difference? So what is important is to have a material that is compatible with the environment where it is used. There is a standard on soil biodegradation, is EN 17033, that tell which kind of feature the material has to have when used in farming activity. That's it. Again, yes or not? The answer is yes. If not, complain the EN 17033 cannot be used. If yes, it uses, and now is used since 15 years.
Mm-hmm. Okay, well, thank you. So interesting. So basically, first of all, with so little amount of the bio-based material or the plastics or the PHA or PLA or whatever is present, number one, and secondly, as long as it passes the EN 17033, the soil is good enough to be used as a compost, and that is what Italy uses at the moment.
Let me, sorry, another, because are important messages. If a material has to be collected for the production of compost, of course, the resulting compost can be used in organic farming. Is if not, the collection of food scraps with compostable packaging will damage the production of compost. So could be a contradiction. So if the material is good for the collection, is good also for the production of compost. But this is so natural, so normal.
Okay. Now there was another question for Katrina, but I don't see it now. Or maybe you have already answered it. Okay, there's one other question here. According to you, what is the main reason for the resistance by the intergovernmental consultation negotiations to fully welcome compostable plastics as a solution against plastic pollution? Any thoughts on that, Katrina or Marco?
I mean, I think that the resistance comes from the confusion in general public and society of, you know, whether materials are truly compostable, can they trust the labeling? And there's a lot of just confusing headlines, confusing data that's being given to people about, for example, you know, when PLA first came in the market in the early 2000s, it was heavily, we didn't have BPI and all these other labeling to show home compost, industrial compost, so on and so forth. And people were very confused by the marketing of PLA's biodegradable. And then they would put their utensils into their garden and they would get furious that it wouldn't break down, and they thought everyone was lying to them. And so it created this distrust, even though PLA is an industrially compostable material. It was designed for that. I think that there's just unfortunately poor data that's led to societal mistrust of the claims. That's my personal opinion, but you know, would love to hear from Marco why there's such resistance there.
I am I'm dealing with compostable plastic since the early 90s. And the result of the success of the composting plastic industry in Italy is because this industry, since the very beginning, was linked with the food waste collection. So our message is we are not the solution of the problem of the earth. Biodegradability is not the solution of the problem of the earth. Could be part of a legislation on eco-design, where we take care of the nature of the carbon used, the energy we use to produce a product. Is a part of a legislation on the environmental feature of a product, but this is related to the eco-design that should be submitted to all the products, not only to a very limited amount of product. Because if we think that biodegradability is the solution for the problem of the litter, I think that we make a very big mistake, and we do not help the development of the industry of truly biodegradable and compostable material. The success of our example is because we are solving the problem of the food waste collection. That is the most important stream of waste we are generating every day. More or less the 35–40% of the waste we are generating in Italy, but this number are more or less the same in all the Western countries. So first, we help to deal with this, and in this way we have generated a very important industry. Then another thing is to have the all plastic material that are based on biodegradability. This is not our scope. I want to clarify. For us, some applications for compostable products are totally wrong. We will do all our best to block the production of the use of compostable plastic for making bottles, or the use of shampoo bottles or durable product, because they do not make any sense from the recycling point of view. And of course, in Italy, I have no idea for other countries, but we will do all the best to support the development of the use of compostable packaging with food, because there is a so huge market for this kind of application. Think to compostable coffee capsule. Coffee is a beautiful product to drink and is a beautiful raw material to make compost. But it's important to have the packaging with the same end of life characteristics. So this is our approach, and probably the reason of the success of our example in Italy. No idea if in the future our plastic could be biodegradable, and I don't know if the message is, okay, these products are biodegradable, you can throw in the environment. So why to collect a banana skin is biodegradable, we can throw in the environment. To me, is a wrong message.
Mm-hmm. Yeah. Okay. Thank you, Marco. So there's another question here. What work is being done to have PHA added to Consumer Goods Forum, EMF, Recyclas, and APR guidelines? When will that be completed? I'm not sure that I know all the acronyms, but is there anybody who can handle that question here? Katrina, do you know those acronyms or?
I'm just a polymer scientist at the end of the day, so I have no idea when that will happen. So I'm not sure if others have a note from the Go PHA team, but I apologize. And I just wanted to let you know, I did type out, I was worried we were running out of time since it's 8:30, so I did type out several answers
Yeah,
in
I
the
appreciate
answered
that
part.
very much. Yeah, thank you. But okay, I had one other question. This is the same question that has been asked also in the platform here. So Katrina, can you comment a little bit on the cost of PHA made currently via fermentation versus the chemocatalytic pathway that you have mentioned? Are there differences? Is there any kind of a forecasting or estimation that has been done so far?
Yes. So our question here is exactly right. Yes, the current chemocatalytic route is an expensive route as well. And I think, we've seen great strides being done on the PHA production route from the biofermentation to reduce costs. We've seen costs go down every year. And I believe, it's still a very wide range depending on the applications you're designing for, whether it's packaging or pharma. I think currently our PHA costs on the packaging piece is somewhere between, $3 to $4 a kilogram, much higher than still conventional plastics, but getting lower. From the chemocatalytic side, this is brand new technologies and it's still quite expensive. But I love to tell the world that 70 years ago, when polyethylene came on the market, it was $4 a kilogram, which with inflation today would equate to something like $40 a kilogram. And so it was highly, highly specialized new material. And over time, with supply and demand and improved infrastructure, now it's 75 cents a kilogram. So I think sometimes we get scared off from progress and innovation because of high costs, especially when it comes to plastics and polymers. But that's our job, and my job is to reduce that cost, reduce the emissions as much as possible. But those materials I was showing, that's still gram level production. We're very new, and we're going to keep working at it to reduce those costs.
Yeah. Okay. Great. Thank you. Any other questions? Let me check the Q&A. I know we have reached the 1 hour mark here, but if people are willing to stick around. So there is another question for Mark. For Marco. As compostable plastics become more widespread, what steps are being taken to prevent contamination in both the composting and recycling streams? And how could global policy frameworks like the UN Treaty might mitigate these risks?
I can tell or give the numbers I have for Italy, of course.
Yeah.
As I showed before, there are less than 100,000 of compostable products sold in the Italian market. At the same time, in Italy, there are more than 2.5 million of plastic material. This means that compostable material are a very limited amount, and as I told before, more than 75% of this product still are in the food waste stream. So if we see 10,000 or 15,000 tons of compostable plastic in 2.5 million ton of plastic waste stream collected, this means nothing. Also, if I double the number, of if I multiply 3 or 4 times, we are speaking of a non-product, a non-problem today. And we are speaking every day with the citizen to how to recognize compostable items and to put where to put compostable items. So I expect to see a decrease of compostable plastic in the plastic waste stream, and vice versa, of course. Today, there is a huge contamination, but we can work in order to decrease the contamination of the food waste collection and transport and recycling of conventional plastic. So I think that we are putting too much question on this issue more than to see the benefit or what can be achieved now. So the problem is that we have a legislation that obliges a European country to make mandatory the food waste collection, and only 1/3 of the food scraps generated in Europe are source separated. 2/3 are today sent in a landfill or incinerators. This is the problem, not the contamination. I would be happy to discuss about the contamination if we collect all the food scraps all over Europe. But this is not we are not here. We are speaking of problems that are not problem, and we forget to see the true problems.
So, so what you're saying is, if the number of compostables increased, if there was proper labeling and education, consumer behavior, obviously, so these would reduce plastic contamination. But also, there is so much plastic relative to compostable materials that's used that there is bound to be some contamination. And I know that I was recently at an industrial composter, and they told us that every day, relative to the amount of material that they receive, which is not a lot, it was a small composting place, that 2 people spend at least 2 hours picking what they see are, contaminants before all that material go into the composting. So this is going to continue. And probably, as you said, that with proper advertising, consumer behavior, and labeling, so that the consumer can recognize compostable versus not compostable, these problems will go away. Okay, great. Let's see. I think we have answered all these questions that are here on the Q&A list. Any other thoughts, any last comments from Katrina? I would like to start with you, give you the floor so you can maybe make a last few comments.
I mean, my last few comments are definitely just as we think about improving waste management infrastructure, which is absolutely critical here. Sustainable alternatives will never be sustainable unless there's improved waste infrastructure in place. And so while I do really believe in that part of the UN Plastics Treaty and support that, I think it needs to go hand in hand with continued innovation of sustainable alternatives and new materials, because there's a reason our recycling rates are so low. And it's because the materials we use today are not working in a recycling ecosystem as we had hoped it would. So as we develop new materials, we should be developing with recyclable by design in mind.
Thank you. Okay, Marco, any additional thoughts, last comments?
Katrina mentioned the plastic treaty. That is a big issue for our industry. From our side, biodegradability is not the solution for the problem of the earth, but this kind of product can play an important role in order to decrease the footprint of our industry. To do it, we need clear standards, norms, and to work on eco design before then to speak about recycling. So it's important to push the brand owners, the system to go with a product with a lower environmental footprint. So the use of renewable resources is important, but we need the legislation in order to push it. If not, the competition is only on price. So I fully support what Katarina told us, but as a person that is working every day managing a contract with local authority, we have to make this industry sustainable also from the financial point of view. We need clear legislation. Innovation is not immediately less expensive than conventional product. To support innovation, if the innovation is considered good for the environment from the social point of view, we need clear legislation. If the plastic treaty do not understand that these products are different and cannot be considered as the standard product, we lose an important opportunity to make a good product and to generate a new innovation that is resident in Europe and in US. And the risk is to compete only in price with Eastern country. That is not good for us.
Yep, well said. Thank you very much, Marco Versari, and thank you very much, Katrina Knauer. And to all those who attended, thank you very much for your time. I hope that this was insightful in our journey towards more sustainable and circular economy. And with that, I would like to end today and have a great rest of the day or evening, wherever you are. Okay.
And thank you
Bye-bye.
for your effort. You are
Thank you
doing
all.
a very good work. We need
Yes.
many days like this. Thank you so much.
Agreed.
Thank you.
Thank you,
for that.
Marco. Thank you, India.
Thank
Bye.
you, Katrina.
Yeah.
Ciao.
Take care.
Okay.
Ciao.
Ciao, ciao.